Hello class, I am Mr. Sutton, and today we're going to be talking about quadratic and linear systems. So first thing we're going to talk about is graphing quadratic and linear systems. So here we have an example. So when we're talking about graphing quadratic and linear systems, that means we have two equations. One is a quadratic and one is a linear equation. So this is on the set of axes below. Solve the following systems of equations graphically and state the coordinates of all points in the solution set. So in a moment, I'm going to switch over to Delta Math and actually do the graphing and show you how to do that. But before we do that, we want to make sure we're ready to graph. For the linear equation, you want to make sure it's in standard form, y equals mx plus b, in slope-intercept form, which it is. We have our m value and our b value, so this should be easy to graph. Our quadratic, on the other hand, is not in slope-intercept form, or excuse me, not in vertex form, so it makes it a little trickier to graph. So in order to graph it, I think what we want to do is find the vertex first. So remember, to find the vertex, it is x equals negative b over 2 times a. That's how you find the x value of the vertex. So we have negative 4 is our b value, times 2 times 1 is our a value. So that would be 4 over 2, which equals 2. So our x value of our vertex is 2. And then we can figure out our y value by just plugging in our x value here. So we plug in 2. Let's see, that would be 2 squared minus 4 times 2 minus 5. 2 squared is 4. Negative 4 times 2 is negative 8 minus 5. So 4 minus 8 is negative 4, minus 5 is negative 9. So this must be our vertex. So with that in mind, we can make ourselves a little table. We know our vertex is 2. Then we want to plug in 2 points around that. Since our a value is 1, I think we could just do 1 and 3. So I'm going to go ahead and plug in 1 and 3 into this to fill out the rest of this table. So when I plugged in 1 into here, I got negative 8. When I plugged in 3 to there, I got negative 8 as well. If you have an a value that is not 1, you might not get as nice of numbers here, so you might want to try different numbers because you want to make sure that these points are points that you can easily plot on Delta Math. But here we have 3 points that we're going to go ahead and plot. So I'm going to go ahead and switch over to Delta Math and plot these two graphs. So here is the same problem that we're looking at, and our coordinates were 2, negative 9, so that's where I'm going to put my vertex, and then 1, negative 8 was our other point, and 3, negative 8 was our other point. So this is what our parabola should look like for the quadratic, and then we can go ahead and plot this other one as well. So we have our y-intercept at negative 5, and our slope is negative 2, so we want to go down 2 to the right 1. So it should look like this. Now our solutions, just like for any system that we graph, our solutions are where the points intersect. So we have 2 intersections here, this point right here and this point right here. So that would be, this has an x value of 0 and a y value of negative 5. And then this point, this has an x value of 2 and a y value of negative 9. So I'm going to go ahead and submit this. Right. So there you go. The key to graphing the parabola is finding the vertex using that vertex formula that you have learned about and plotting some points around that. And then key to graphing the linear equation is making sure that it's in slope-intercept form, graphing the y-intercept, and then graphing the slope. Then you just want to find the 2 points of intersection, and those are your solutions. So now back to this, another type of problem we have here. Graph the following, or excuse me, solve the following system of equations algebraically. So now without graphing, we want to come up with a solution. Now, if you'll recall, previously with systems of equations, we learned 2 methods to solving systems, and that was elimination and substitution. Also graphing, but we already did that. So we are going to be using substitution to solve this system here. And you'll notice that we already have these equations solved for y. So we can go ahead and you can think about this either way. Substitute this in for y over here, or substitute this in for y over here. But the key is that we want to set these right sides equal to each other. Okay, since both of these right sides are equal to the same thing, they're both equal to y, we can substitute and set them equal to each other. And then from here, now we have an equation that only has x values in it. So what we want to do is first get everything on the right side, set it equal to 0, and then we'll be able to factor and solve for x, find the zeros of this equation, the roots, and then once we have the x values, we can plug those back in to either of these equations to figure out the y values. So first thing I'm going to do is get everything to the right side of this. Now that I've done that, you should have x squared plus 12x plus 35 equals 0. Now we have something that we can factor. So we want to do some type of ACB tree. A times C, that's 1 times 35, so that's just 35. We want to figure out 2 numbers that multiply to give us 35, add to give us 12. So I'm thinking 7 and 5 would work there. They both have to be positive, so 7 times 5 is 35. 7 plus 5 is 12, so that's how we want to split up our middle term. So from the first 2 terms here, we can factor out an x plus 7. From the second 2 terms here, we can factor out a 5, and we're left with x plus 7. So our factors are x plus 5 and x plus 7. Now we want to set each of those factors equal to 0 separately and solve them for x. So we have x equals -5 and x equals -7. Now our solution, just like in the graphing example, our solution has to be 2 coordinates. So we need not only x values, but y values as well. So we only have half of our answer right now. We have -5, but we still need to figure out the y value. We have -7, but we still need to figure out the y value. So in order to figure out the y value, we just have to take these x values and plug them back into one of these 2 equations up here. Doesn't matter which one, because remember, this is where the 2 equations intersect. So both of these equations contain this point. So I'm going to pick to plug into this equation just because the math is a little simpler here, less room for error. So I'm going to say y minus, and then I'm going to plug in, y equals minus, and then I'm going to plug in my -5. So minus a -5 is the same thing as +5. So then I have 5 minus 8. So that would be -3. Now I'm going to do the same thing with my -7. Minus a -7 is a +7. And then 7 minus 8 is -1. And that's it. A lot of work to do on those, but all stuff that we have done before. This is a new way of combining these steps. So again, the first thing we did was substitution. We have y equals y here, so we can set these equal to each other. And then the next thing we did was we got everything on the left side of the equation, so that it was a quadratic equaling 0. Equal 0 is important because that allows us to factor, and then we could set our factors equal to 0 to find our x values. And then once we have our x values, we can plug those back into one of these equations in order to find our y values that correspond to those x values. All right. So those are your coordinates. These are the coordinates where these two lines intersect on the graph. And so the only other thing here is you might see some where it's not already solved for y. So in this case, the first thing you would want to do is to solve this equation for y so that you can do substitution. So I'm going to go ahead and do that. And then from here, you can go ahead and do substitution with these two equations, set them equal to each other. So I'm going to go ahead and do that. And then from here, you just want to get everything to the left side of the equation, so it's set equal to 0. So now we are ready to factor. Here we don't need to do an A-C-B tree because we don't have a C value. Their C value is eliminated. So here we can just do a GCF. 2x would be the GCF of this. So we'd be left with x plus 5 equals 0. So we set our two factors equal to 0 separately and solve them for our x separately. So we get x equals 0 and x equals -5. So that is half of our answer. Now we just have to plug these back in to one of our original equations in order to figure out the remaining y values. So I'm going to go ahead and do that. So I went ahead and plugged them into this equation right here rather than this one up here. The reason for that being that this is already solved for y, so all of my math is already on the right side. Versus if I plugged it into x here, I would have to do a little bit of algebra again to get y by itself. But I've already done that, so no need to do that again. So I think it's better to just plug it in here. And when I plugged in 0, I got y equals -15. And when I plugged in -5, I got y equals -30. So these are your answers. If you have any questions about any of this material, please ask your teacher for help or come to office hours. And otherwise, have a good day.